I got this feeling inside my brains. It goes electric wavy when I make them A's. All through 4th grade, all through my school, we're flying up no ceiling when we're in our zone. I've got that sunshine in my pocket, looking forward to a good day. I feel I can do everything when I try. I can't stop myself from learning, moving up academically. Room unlock the way we rock it, so don't stop.
Hello students, I hope you are having a wonderful day. Today we're going to be learning about why do we need to know about fractions, benchmark fractions, TEKS 4.3F. So today we're going to be learning about the 4 different types of benchmark fractions, and it's going to help us to estimate. So when we're looking at fractions, we're going to say, which one's bigger or which one's closer to a benchmark fraction, and that way we can see, oh, I know which one's bigger, which one's smaller, or I know where it's at on the number line, okay? So, remember, if you see this little guy, pause the video and write down what is on the screen, okay? Alright, our objectives. Students will know how to identify the benchmark fractions on a number line. Students will understand how to use the benchmark fractions to estimate where a fraction is on the number line. And then students will be able to share in a group discussion how to evaluate the reasonableness of the sums and differences of fractions using benchmark fractions, which are 0, 1/4, half, 3/4, and 1, okay? So make sure you write it down, referring to the same whole, okay? Make sure you write down those 4 fractions. 5. Those 5, well, technically there's only 3 fractions and the other 2 are whole numbers, but you know what I mean, okay? So make sure you write those down. And here's the Spanish version, alright? Essential questions. How do you use benchmark fractions to evaluate reasonableness? Okay? If you don't know what reasonableness, it means does it make sense, okay? So you need to make sure that when you're working out problems, you ask yourself, if I get this answer, does it make sense? Okay? If Mr. Rios asks you, what is 2 times 2? And your answer is a giraffe, ask yourself, does this make sense? Okay? That's what reasonableness means. Important vocabulary. Alright, so we have 3 important vocabularies: unit fraction, simplify, and benchmark fractions. Remember, a unit fraction is a fraction with a numerator of a 1 that represents 1 part of whole. For an example, all of these are unit fractions because they have a 1 as my numerator. Simplify means to express a fraction in simplest form, okay? For an example, I have 2/8, and if I divide by 2, both my numerator and my denominator, then I get 3/4. That just means that I just made it into its smallest unit, okay? And then we have benchmark fractions, fractions that are commonly used for estimation. For an example, 0, 1/4, half, 3/4, and 1, okay? Here is a fractions video. Let's go ahead and watch what we're going to learn today.
You know, fractions are tricky. And if you want to compare fractions, sometimes it's actually useful to do something kind of an intermediate step, to use a benchmark to actually compare fractions to see if one's bigger or smaller and so forth. Sometimes the benchmarks actually make life a little bit easier when we're dealing with some of these more interesting, fun, but tricky fractions. Let's have an actual fun example where we're going to go out onto the actual great outdoors and look at some people that have been running. Let's check it out. So Sandra ran 7/12 of a mile, and Lamar ran 5/8 of a mile. And the question is, who ran the furthest? All right, well, see, these fractions are kind of hard to kind of compare to each other. 7/12, 5/8. It's a little bit tricky. Well, but if we see if we can actually use a benchmark, and by the way, a very, very famous and useful benchmark is a half. If we use a half as a benchmark, we can now compare both of those fractions, both those numbers, to a half and see if we can conclude anything. So let's think about it together. So we know that Sandra ran 7/12 of a mile and Lamar ran 5/8. Okay, so let's think about Sandra, and let's take a look at a number line. So here's a number line, and this is going to represent Sarah's run. And notice that I've marked down, I've broken down the entire unit, which is a mile, into 12. So 1/12, 2/12, 3/12, 4/12, all the way out to 11/12, and then 12/12 is just 1. And then I've also noted on the top here, just 0, 1, and then right halfway in between, a half. So it's much simpler on top, but we're going to be able to compare to the half and use half as a benchmark. So she ran 7/12 of a mile. That means that we have to take a look at 7/12, which go all the way out to 7/12. And we can visualize that with this bar. Running in, running in, running in, running in. And you can see that goes right to 7/12. There it is. I'm going to pull it down here so we can see it better. And let's now use 1/2 as a benchmark. If we use 1/2 as a benchmark, what do I see? What I see is that 7/12 is actually greater than a half. And you can see that if I lift it up even higher, you can see that the red frame extends past a half. So we see that 7/12 is actually greater than a half. Great. Now, let's take a look at Lamar. Well, here's Lamar's number line. His units, in terms of units distance, in fact, put it way up here, is in eighths. So we have 1/8, 2/8, 3/8, 4/8, and so forth. And again, I want to use 1/2 as a benchmark. So on the top here, I have 0, 1, and then right in the middle, I have a half. Great. And now he ran 5/8, so that means we go all the way out to 5/8 of a mile, so right to here. And now we see that our benchmark still tells us that 5/8 is actually greater than a half, and you can see that too. But what's interesting is that if you notice, when I put these together, these align right along the 1/2 line, and so what we see, all we have to do is compare the extra 1. So we see 1, 2, 3, 4/8 is equal to that 1/2, and we see 1, 2, 3, 4, 5, 6 twelfths is equal to the 1/2. And so the only thing that we now have to compare, since we used the 1/2 as a benchmark, is just this extra 12th compared to the extra 1/8. And just visually looking at it, we can see that a 12th is actually less than an 1/8. And so therefore we can see that this red box of Lamar's is actually longer than the red box of Sandra, which means that Lamar, in fact, ran a further distance. So we can actually write that in math terms if we want to, which is kind of fun to do. We can write this in a couple different ways. One way is we could say that 7/12 is less than 5/8. And the way we denote that in math is we use this symbol. This is the less than symbol. So 7/12 is less than 5/8. See how tiny it is here? So that's kind of the small value. And see how big it is here? That's the big value. So 7/12 is less than 5/8. There's another way of writing it. I could say it this way. I could say, oh, well, you know what? 5/8 is greater than 7/12. And then the symbol looks like this. This is the greater than symbol. So there are lots of ways of writing it mathematically. This is like the top secret math code for saying in words that 7/12 is less than 5/8 or 5/8 is greater than a 7/12. In terms of the actual question that we were asked, we can see that since 7/12 is less than 5/8, 5/8 is greater than 7/12, then we see, in fact, that Lamar, in fact, ran the furthest. Lamar, in fact, ran the furthest. So we were actually able to take a look at a benchmark, and then once we realized that, in fact, we can, for the purposes of seeing which is larger, which is further, we can ignore all of those. We can ignore all those because they all line up along the 1/2 line. We're just comparing this tiny 1/12 to this slightly larger 1/8, and we see, therefore, this is bigger. Everything else agrees, and so, therefore, this whole thing must be greater than that whole thing. And we see Lamar ran further. Really interesting to see that benchmarks will allow us to take fractions that seem difficult to kind of relate and compare to each other and actually make that comparison child's play. So the next time you're running out there, realize that while you're running, in fact, you're not only jumping over hurdles, but you're also passing benchmarks. Have fun thinking about math. I'll see you soon.
Awesome. So we just looked at the benchmark fractions video. It was very interesting. I hope everybody learned something. So what we're gonna do now is we're gonna stop the video here and we're gonna get some notes tomorrow, and you're gonna learn so much, okay? I hope I see you tomorrow. Have a great day. Bye.